All right, in 4.6 today, we're graphing tangent and cotangent, cosecant, and secant. Don't be intimidated by the way these graphs look. They're actually, tangent is a lot easier to graph than cosine and sine. It doesn't have a very lengthy process, finding the period, dividing by 4, all of that. And then we're going to graph tangent first. That's our last basic trig function. Then we're going to start graphing the inverse cotangent, which is very similar to graphing tangent. The only thing is cotangent is, of course, just flipped. It's reverse. And then cosecant and secant. You don't have to draw this graph. We're going to graph an example or two with tangent unless you just want to. Your tangent function, A tangent bx minus c. And once again, these values tell you what your graph, like different components of your graph. A is still your amplitude, just like it was for sine and cosine. That tells you how far up and down you can draw your y-axis. And the expression that follows tangent, whatever's with x, is, you're going to see in a minute, it's vital in finding where to draw your asymptotes. And that's always the first thing you do when you're graphing tangent, is you're going to draw your asymptotes. And then I'm going to show you an easy way to find your 3 key points that are in between. Okay, so if you'll notice from this basic tangent graph, notice that it has a period of pi.
Good morning, Grissom High School. Please rise for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Now for the announcement.
Ninth grade teachers, please remember to go to Coach Steele's room for PSTs during your planning. Have a great day, Tigers.
All right, the period for tangent, unlike sine and cosine, is pi. The asymptotes, wherever your asymptote starts, or one asymptote starts and the other one ends, will always complete one full period of tangent. So notice that this particular period that we have graphed, your vertical asymptote is at negative pi over 2. The next vertical asymptote is at pi over 2. And the reason that tangent and cotangent, you're going to see, have vertical asymptotes, and cosecant and secant, if you look at your unit circle, tangent of pi over 2 or tangent of 90 degrees is undefined. The tangent of 3 pi over 2 is also undefined. And of course, as we keep adding rotations or subtracting rotations around the unit circle, pi over 2, negative 3 pi over 2, then it's also still undefined. You wind up with a coterminal angle. Your range for tangent is all real numbers. Remember, for sine and cosine, our domain was all real numbers. Your domain for tangent is slightly different, and it's based on, of course, where your asymptotes are, and your domain is undefined in those areas. So for this basic tangent graph, your domain would be all real numbers except your odd multiples of pi over 2. You've got a vertical asymptote at 1 pi over 2, 3 pi over 2, 5 pi over 2. You'll have one at 7 pi over 2. Okay, you don't really have to write down this vertical asymptote because that's going to change based on, of course, what you're given with bx minus c. But it does have vertical asymptotes in a tangent graph. You always have, this is how we're going to graph it. You're going to draw your asymptotes first. You've got x-intercepts that are always halfway between your asymptotes. So that'll be the first point we graph. Then you're gonna have another point, this in the middle of that x-intercept and your asymptote. It will be down at your amplitude, and then you'll have another point that's 3/4 of the way into the period, or halfway between your x-intercept and that second asymptote. It will be up at your positive amplitude. So you've got x-intercepts in the middle of your asymptotes, and then you've got points that are 1/4 and 3/4 of the way between your asymptotes that will have y coordinates of -a and a. So point 1/4, 3/4, and it's going to be up at or down at -a and then up at a. Okay, here's our steps to graph tangent. Very similar, also graphing cotangent in a minute. The first thing you're going to do is set bx minus c between -pi/2 and pi/2. So you're going to first find two consecutive asymptotes that will, of course, graph one period. You're going to solve this inequality for x. And it's always -pi/2 less than bx minus c. So whatever follows tangent, you're going to plug in the middle between -pi/2 and pi/2 and solve for x. Then you're going to sketch your graph from that point. You have an x-intercept that is in the middle of your asymptote. So find the x-intercept in the middle of asymptotes. How you get your other 2 points, you'll have a point 1/4 of the way into the period. It will be up at, or it will be down at -a if tangent is positive. It will be up at +a if you have negative tangent. You have a point 3/4 of the way into the period, up at +a if tangent is positive, or down at -a if tangent is negative. And then you just draw another asymptote, see how far apart your first 2 asymptotes are, draw another one in either the left direction or the right direction, repeat that process to graph another period. So in some cases, they're going to tell you actually what particular periods they want you to graph tangent, cotangent, cosecant, secant in, and that's what you have here. The first thing we're going to do, of course, is find where a pair of asymptotes would be. So you're going to take what follows tangent, what's in bx minus c's spot, and you're going to plug that in between negative pi over 2 and positive pi over 2. Create a compound inequality to solve. If you're solving for x, how do you get x by itself? What are you going to do to all three areas? You're going to divide by 2. So if you divide 1/2 by 2 and negative 1/2 by 2, what are you left with? If you take a half and you split that in 2, how many? Good, you got 4. So this will be negative pi over 4. This asymptote will be at positive pi over 4. Okay, what is your amplitude? Amplitude is 3. That's at least how far up you need to draw your waxes, how far down you need to draw your waxes, at least a 3, if not 4. Since my asymptotes are in pi over 4, then that's what increment I will go by on the x-axis. So whatever you get for your asymptotes, just go by that. And you need some definitely in the negative direction and the positive direction. Okay, the first thing you're going to do is draw your vertical asymptotes that you just found at negative pi over 4 and positive pi over 4. Then up at the top in the directions, they wanted you to draw a graph, the tangent function out to positive 3 pi over 4. And how you know where else to draw your asymptote, of course, is you can just see how far apart they are. So they're 1, 2 places over. So your next asymptote is going to be at 3 pi over 4. Or your period here is pi over 2. So let's graph one period. Let's look between here. You've got a point that is halfway between your asymptotes on the x-axis. And this was a positive tangent graph. So I have a point that is in the middle of this x-intercept and this first asymptote, and it's going to be down at my amplitude of -3. So you just kind of estimate halfway would be out here and then go down to your negative amplitude. And that point is your point 1/4 of the way into that period. You've got another point that's 3/4 of the way or halfway between that x-intercept and your second asymptote up at your positive amplitude. And just now you can sketch your curve approaching the asymptote and then approaching that asymptote. And repeat the process. You've got a point halfway between asymptote x-intercept down at negative amplitude, halfway x-intercept that asymptote up at positive amplitude. Okay, how do y'all feel about tangent? Y'all think it's easier than sine and cosine? Maybe not sure yet. All right, your domain, you've got asymptotes at -1 pi over 4, pi over 4, 3 pi over 4. Your next one would be at 5 pi over 4, 7 pi over 4, and so on. So your domain is all real numbers except odd multiples of pi over 4. All real numbers except odd multiples of pi over 4. Your range for tangent, of course, notice these curves are going to go up and down forever. They're going to approach they're going to approach those vertical asymptotes and get very close to it, but without bound. So your range is all real numbers. All right, graphing cotangent is pretty much the same process, except for your basic, graphing cotangent. Same process as tangent, but it's reversed. So a basic cotangent graph you would have your vertical asymptotes at integral multiples of pi, and the curve inside is going to go this way. So it kind of look like that. That's a terrible sketch, but anyway. Your period for cotangent is still pi, just like tangent. Domain is all real numbers except pi multiples. Range is all real numbers. Okay, the only thing that's different about cotangent from tangent, you're going to have a point that's 1/4 of the way, but in this case, it's going to be up at positive A if you have a positive cotangent, down at negative A if cotangent's negative. You'll have a point 3/4 of the way. It will be down at negative A if cotangent's positive, up at positive A, cotangent is negative. All right, another difference for cotangent, you're gonna find your asymptotes first, but you're gonna set bx plus c between 0 and pi. So whatever follows cotangent, you put in between 0 and pi and solve for x. Okay, you've got to subtract pi over 4 from all three areas. So you end up with an asymptote at negative pi over 4 and 3 pi over 4. Your amplitude is 3. So you need to draw your y-axis up to 3, negative 3 at least. Okay, how you know how far out to draw your x-axis? It goes, one period goes from negative pi over 4 to 3 pi over 4. So that is pi. And you want at least 2 periods. So I know one period stops at 3 pi over 4, and I need another whole period, which will take me to 7 pi over 4. All right, draw your asymptotes in negative pi over 4 and 3 pi over 4. Just like tangent, cotangent has a point on the x-axis halfway between your asymptotes. So halfway between my asymptotes would be here at pi over 4, 0. You're going to have a point that's halfway between that and the first asymptote. And in this case, it's going to be up at your positive amplitude, which was 3. You have a point 3/4 of the way into your period or halfway between your x-intercept, second asymptote. For cotangent, it's going to be down at your negative amplitude. And then draw one more period. So of course you can either add pi, which would be 4 pi over 4 to get 7 pi, or you can just count how many spaces are between asymptotes to see where your next one should be drawn. Okay, do y'all have any questions about graphing tangent and cotangent? Okay, your domain, you have, notice that your asymptotes are at -1 pi over 4, 3 pi over 4, 7 pi over 4. So all real numbers except every other odd multiple of pi over 4. So all real numbers except every other odd. Doesn't start with, it skips 1 pi over 4, goes to negative pi over 4, 3 pi over 4, 7 pi over 4. And your range is all real numbers.
Do you want your extra copies from the front door? Nobody ever answered. I'm throwing them in the trash if no one finds them. Do you care?
I can go get them.
They've already delivered them to my room because I never went and got
Oh, okay.
them.
It don't matter. Yeah, I've got plenty of extra copies, so you can toss them. Okay, we'll graph one cosecant and one secant, and we'll be done. I know y'all love this so much, so hang in there. Yeah. Good news is, same process applies for these graphs. Okay, how you graph secant or cosecant, the first thing you're actually going to do is graph the same function, but you're going to replace sine with cosecant, and you're going to replace cosine for secant. So you're going to graph the sine or the cosine function first. Period for these, just like sine and cosine, is 2 pi. All All right, where your sine and cosine curve crosses the x-axis, so at your x-intercepts, your cosecant and secant graph will have vertical asymptotes. So wherever it crosses the x-axis, we're going to draw vertical asymptote. Step 3. At your relative maximum at your relative minimums on your graph, which is simply, of course, top of a hill, bottom of a hill. At the relative maximum, you're going to draw a parabola from that relative maximum point going up and approaching your vertical asymptotes. At your relative minimum points on the sine and cosine curve, wherever you have a point at the bottom, you're going to draw a parabola going down, approaching those vertical asymptotes that are on either side. All right, the first one we're going to look at is graphing -3 secant of x over 2. And they tell us to make sure we graph from negative pi to positive 5 pi. Once you do all the work, figure out your period, graph it, that should definitely not be an issue. So what we're going to do to graph secant, I'm going to replace that with cosine. And we're actually going to graph -3 cosine x over 2. So just like we did in 4.5, find your period, amplitude, like the amplitude is going to be 3. Period is 2 pi over b, which is 1/2. So your period is 4 pi. Okay, to help us get our y values, draw a small sketch of what the cosine curve, what the basic cosine curve would look like. This is a negative cosine curve, so it will start on the y. Basic graph would look like that. So this first and fifth y value would be down at your negative amplitude. Bless you. There is no vertical shift. There's no d value at the end. So your first and fifth y will be -3. Second and fourth will be 0. Your third y value will be up at +3, your amplitude. Okay, let's find our x, our 5 x's to go along with those y values of -3, 0, 3, 0, -3. There is no phase shift. We don't have anything added or subtracted with x, so there's no phase shift. When there's no phase shift, your first x is what? Your first x is 0 if there's no phase shift. Take your period, divide it by 4 to see what you add to each x. So my period was 4 pi. Divide that by 4 and you get pi. So your next x is going to be pi. Next will be 2 pi, 3 pi, 4 pi. Okay, your amplitude is 3, but for cosecant and secant, you always want to make sure you go out at least 1 past that amplitude. So I'm going to draw my y-axis out to 5. And remember, when we're graphing sine and cosine, on the x-axis, go by the increments x is in. So we're going to go by pi. And they wanted me to graph, make sure I graph periods out from negative pi to 5 pi. Okay, the first thing, let's graph our cosine curve. So 0, -3, pi 0, 2 pi 3. And since they wanted me to draw it between negative pi and 5 pi, I just follow the same pattern. So this curve is going to come back up. Okay, there's our basic cosine curve. This is how you graph secant. You're going to draw asymptotes everywhere this graph crosses the x-axis. So at all of your x-intercepts, there is a vertical asymptote. Okay, the next thing you're going to do that we wrote down in our steps is that all of our relative minimums, which are these bottom points, and any relative maximums, you're going to draw a parabola. So from this relative minimum, this point here, I'm going to draw a parabola going through that point, approaching both asymptotes. So draw a parabola going down, approaching both asymptotes. And do the same thing here. Okay, at your relative maximum point, you're also going to draw a parabola approaching both asymptotes, passing through that point. All right, your cosine curve is in green. Your actual cosecant graph is the asymptotes and the other parts. So when you're determining domain and range, don't pay attention to the green graph, to the graph of cosine. Your domain, you've got asymptotes at every odd multiple of pi. So domain is all real numbers except odd multiples of pi. Okay, if you're just looking at this part of your graph, to figure out the range, notice that it's going to go down forever, but it's going to come back up where? To -1. So my range is from negative infinity to -1 bracket, but of course, notice there is a gap, union, then it picks back up at, wait, that should be -3, sorry. -3, my bad. -3, then it picks back up at +3 and goes up forever. All right, how do y'all feel about cosecant graph or secant and cosine? All right, last one. This is your number 4, number 5 in your notes. I'm going to post. All right, we're going to graph y equals 2 cosecant of x plus 2 pi. First, we're going to graph the sine version of that function. Your period is 2 pi divided by b, which is 1. So my period for this graph is 2 pi. This graph has a phase shift. You do have a C value. It's always the opposite divided by b. So I have a phase shift of -pi/2. Amplitude is 2. All right, to help determine y values, this is a positive sine curve. Basic sine curve, positive looks like this. Your first, third, fifth y value is 0, and there's no vertical shift, so it will be that. First or second y is up at your positive amplitude, fourth y down at your negative amplitude. All right, to help us get our x values, there is a phase shift, so that's your first x, -pi/2. Take your period, which was 2 pi, divided by 4, you get pi/2. That's the interval you're adding to each x value. Killing some trees. I can't throw that away right now. Oh, look at that. Just send it to me.
I'll fix it right away.
Okay, do it. Thank you. Okay, when you graph your sine curve for this function, this is one period. Draw your asymptotes through the x-intercepts. One period for sine is actually going to give you 2 periods for the graph of cosecant. Then you draw a parabola from your relative maximum, relative minimum, your domain is all real numbers except odd multiples of 2 pi. I mean, pi over 2. Odd multiples of pi over 2. Range is from negative infinity to negative 2, union 2 to infinity. Your math lab is multiple choice. Pick which one matches this graph. I don't think they even make you graph any. You definitely need to practice some of these on paper. Next week or the week after, I'm going to give you 4 to graph, and you're going to have to turn in. You're going to have to give me domain, range. You're going to have to graph it, label your axes, and know all the different components about it. So make sure you're practicing some of these by hand on paper. All right, if you don't have any questions, work on your 4-6 math lab.
The frame for folders.
Mm-mm.
Who brought us this?
I don't remember, who was it in the group meeting? Someone was asking about it. I don't know.
Math group me or big group me?
I think big group me, but just, I just hang on to it.
I'm just gonna put it in group me. I'll be glad to then have it back. I'll just get a run at it.
Yeah,
I don't need one more thing.
that's what I was gonna say. I just hang on to it until somebody asks or either just post it. Yeah, go ahead.